Hello and welcome back to the Orchestrator for Developers tutorial series. In the previous videos, we learned how to publish a package, create a process, and manually start a job. We've seen that robots can start performing jobs right away, but what if we want our processes to be executed in a planned manner? In order to answer the question, we need to learn how to schedule a process. Let's begin. As a first step, let's open the Schedules tab and then select the Add icon. We can easily give your schedule a name. We'll call it Demo Schedule. Next, we'll select the process that we created earlier. We also have the option to select the time zone, but we'll go with the default option in this demo. Moving on to the Trigger tab, we can select the specific time range that should pass between one process execution and the next. Once again, we'll stick with the default 1 minute option. We could set a different interval. Our process can run once every 5 minutes, hourly, daily, and so on. Moving on to the Execution Target tab, there are 3 options. The first one is All Robots, which is quite self-explanatory. The second one is Specific Robots, which enables us to choose a specific robot. If we select Allocate Dynamically, Orchestrator assigns the execution to the first robot in the environment that becomes available. Now that's useful when multiple jobs must run simultaneously to maximize efficiency. We'll return to the previous tab and select Robot 2. Please note that the Actions tab enables us to perform specific actions, such as stopping or killing the job after a given time, as well as disabling the schedule on a given date at a certain hour. The Parameters tab allows for setting values to the arguments in our process. Let's type a value here, as our argument does not yet have one. We'll click Save, and then click Create. Our schedule is now created. It should run in only a few seconds. And it works! Finally, keep in mind that you can easily remove, disable, or enable a schedule by selecting it and clicking one of the icons displayed above the schedule list, like this. And that was all for today. Thank you for watching. Hello and welcome back to the Orchestrator for Developers. Hello and welcome back to the RPA Production Ready Essentials training. Today, we'll learn how to update an existing package and run a job with parameters. Now, in the previous videos, we built a workflow that opens Notepad and types a specific message. Today, we'll learn how to turn our message into a configurable one by making use of input arguments. To begin with, let's create an input argument. We'll replace the string in the type into activity with the value of this argument. We proceed by publishing the new version of our process, but not before adding release notes. The next step is to upgrade the process to the latest version. Let's go to the Processes page. The icon here indicates that a new version of the package is now available. Let's take a closer look at the available versions. The current version is the one that we published in the previous tutorial. Now, before upgrading, it's recommendable to check if the values of all the parameters are the correct ones. We'll set the value of our parameter when we start a job. We should also review the change log, which can be found in the Packages tab. We can see it if we click this button here. There are all our package versions and their respective release notes. Okay, we can now upgrade our process safely. To upgrade the process, we can simply click this button. Now, in case we need to restore one of the previous versions, we can always use the rollback option. Now that the process is up to date, we can create a job with parameters. As before, we'll click the play button and select our process. To set the value of the parameters for this job, we'll open the Parameters tab and click the Edit button. Let's type Hello UiPath Academy and click Save. Let's have both robots execute the workflow. Let's see what happens. And there it is! So, today we've learned how to upgrade packages and set job parameters in UiPath Orchestrator. That was all for today. Thank you for watching. Welcome back to the UiPath Production Ready Essentials training. Today, we'll use the workflow that we created in the previous tutorial to illustrate the usage of the assets functionality. The message to be typed by the robot does not differ from one job execution to another, so it doesn't make much sense to add it as an input parameter. However, it is recommended to make sure that our message is easily editable. To achieve that, we'll store the message as an asset. Once we open the Assets tab, we can simply click the plus button to create a new one. Let's type a descriptive name, such as Notepad Message. The drop-down menu next to this field enables us to select the type of data that we intend to store. Let's have a quick look at all the available options. We can store text, Boolean values, integers, or credentials. The default option suits our case, as we want to store the Notepad message, so we can move on. Next, we can add a value, which is the message itself. And then we click Create. OK. Next, we'll update our project in UiPath Studio. To retrieve the value of an asset from Orchestrator, we can use the getAsset activity. We can indicate the asset to be retrieved in the Input section in the Properties panel. Let's copy its name from Orchestrator and paste it in the Asset Name field. Next, we'll create a new variable to store the value of our asset. The last modification required in the workflow consists of adding the variable in the TypeInto activity. Let's run the workflow locally to make sure that it works. Alright, it worked. We can close the Notepad file for now. Next, let's see how we can have each robot display a different message. We'll create a new asset. You might have noticed that there are two tabs in this window, Single Value and Value per Robot. Let's select Value per Robot this time. Once again, we need a name, such as Value per Robot. Now we don't need to change the type, so let's start assigning the values. The section below usually displays all the robots that belong to this specific organization unit, or tenant. We'll select all the robots and proceed by setting their individual value. For Robot 1, we'll write Hello, Robot 1. We'll click Add and move on. Now this value is editable, so we can come back and modify it whenever the need arises. We'll add the second robot, which will type the Hello Robot 2 message. Now we'll click Create to save the asset. Let's update the workflow by including this new asset. Firstly, we need to copy its name. We'll return to our project in Studio, and we can replace the previous asset with the new one by pasting it in the Asset Name field. Now let's publish the project again to make sure that the updated version is sent to Orchestrator. We can see the name of the package as well as the latest version. Let's click OK. Before we start a new job in Orchestrator, we need to upgrade our process. Otherwise, the two robots still execute the previous version. So we'll go back to the Processes page, select View Process, and upgrade to the version that was published a few seconds ago. Moving on, we'll go to the Jobs page to trigger the execution of the current version. And we'll enable both robots and click Start. The two jobs are now running. And here's the Notepad window as well. Let's close this file and let's also check Robot 1. The text that we assigned it was successfully written in Notepad. Alright, let's move on. The next topic that we'll address today is the Credential asset type, which enables our robot to log into this application. Now we'll go ahead and create a new asset called UI Demo Credentials. This time we need to pick a different type, namely Credential. Next, we need to provide the username, which is admin, and the password. Credential assets enable us to store passwords securely. When we try to edit this asset, we can notice that the password is not displayed anymore. If we edit the username, we must update the password as well. Now that we've created the asset, we need a workflow, so let's go back to Studio. We'll add a new project, so let's start a sequence called UI Demo Login. Now we won't be able to use the Get Asset activity anymore because it does not work with Credential assets. Instead, we need the Get Credential activity. Next, we'll copy and paste the name of the asset as we did before. To save the output, we'll create two variables, one called password and the other username. Let's have a look at the variables panel. The password is a secure string, but the username is stored in a string variable. The values of secure string variables are encrypted automatically, as opposed to plain strings, which are always visible. We'll add a type into activity to enter the username, and enable the Simulate Type option. The activity that we need to fill in the password field is Type Secure Text. The input is the password secure string variable. Once again, we'll select the Simulate Type checkbox. To complete the process, the robot must also click the Login button, so let's add the final activity in our workflow. Let's see how this works. Everything went fine. We've reached the end of our demo on Orchestrator assets. Today, we've learned how to create assets in Orchestrator and incorporate them into our projects in UiPath Studio. Thank you for watching. Hello, and welcome back to the Orchestrator for Developers lesson. In today's demo, we'll get a better idea on how enterprise implementations actually work by delving into two topics: orchestrator queues on the one hand, and the dispatcher and performer model on the other. Now, queues are very powerful tools in UiPath. They enable work division between multiple robots without having to keep track of complicated rules. As for the dispatcher and performer model, this is a very effective robot setup model, allowing the division of labor between a process that takes care of populating the queue and another process that consumes it by executing the work. Note that we are discussing processes, not robots. As a matter of fact, enterprise implementations rely on the fact that more robots can consume or populate the same queue through the same process. Now, in this video, we'll create a robot that populates a queue using the input data from an Excel file, and a second robot that gets the queue items and performs a simple math operation with them. Now let's start with the dispatcher. Here's the Excel file containing the data that we need, organized in two columns: incomes and payments. What we need to do is to take this data row by row and put it in a queue. The queue has already been created in Orchestrator. Here it is. And as you can see, it's empty. Now back to UiPath Studio, where we'll create the dispatcher robot. Let's start with an Excel application scope. Indicate the input.xlsx file, and then use a read range activity to place the data from the Excel file in a data table variable. Let's not forget to change the scope of this variable to the entire sequence. Now that the data has been read, let's populate the queue. For this, let's start with a for each row to loop through the rows of the data table variable and use the add queue item activity in the body. To make it work, we have to modify the item information field in the properties panel by adding two arguments to match the data in the data table. The first will be incomes with the value row of incomes dot toString, and the second one will be payments with the value row of payments dot toString. We'll leave the direction in and the data type string for both of them, and we'll also have to specify the name of the queue between quotation marks. Hit save and then run. Once the robot ends the execution, we can go to the queue and click View Transactions to see that it has been populated. For each of the newly created transactions, we can access its details and see that it has both arguments, incomes, and payments with their respective values. Alright, time for the second robot, the performer. Let's create a new sequence in the same project and give it a name: Process Transactions. The activity that gets transactions from the orchestrator queues is getTransactionItem. Let's start with that. Add the queue name in the designated field and then create a new variable to store the output of the transaction item. Next, let's add an if statement just to make sure that the transaction item is not empty. For this, we'll use the condition transaction item is not nothing. Now, if you remember, in each transaction from the queue, we have the income and the payment, and we'll need this data separated. For this, let's create two variables of integer type: income and payment, and use two assign activities in the true branch of our if. For each of the two, we'll use the .specific content property after the name of the variable, together with the conversion to integer method. The expression will look like this. And we just need to make sure that the names between the quotation marks match the names of the two arguments from the dispatcher. And give the two assign activities proper names. Once the two variables got their values, let's use a log message to calculate the difference. And since this is the true branch and we know that this will be executed, we'll add a set transaction status activity. Specify the name of the transaction item and make sure that the status in the properties panel is successful. Alright, what our true branch does is to take the two values in each queue item, pass them to integer, and perform a subtraction. So, what if the values cannot be converted to integer? To tackle this, let's use a try-catch for the entire sequence of the true branch. And we'll simply right-click it and select Surround with Try-Catch. Now in the catches block, let's select a new system exception and add another set transaction item activity, but this time with the failed status and with the specified reason: the fact that the conversion to integer was not valid. Now let's save this sequence and return to the main workflow of our project, which is empty at this point. To keep track of the processing of the items in the queue, let's create a new integer variable, counter, and give it the value 1. The first activity that we'll use here is log message, and the message should be processing transaction number, plus the name of our variable, followed by .toString. Next, we'll use an invoke workflow activity and choose the process transaction sequence that we created earlier. Let's also change the name of the invoke workflow activity. After each execution of the invoked workflow, we need to increase the value of the counter variable, and we'll do that by using a simple assign activity. Now it's time to handle the stopping mechanisms of this workflow. Let's add a should stop activity, which allows sending commands from the orchestrator to the robot. Normally, the execution of the performer workflow can be controlled via Orchestrator, and this activity is where the robot will check the command received from the orchestrator and store it in a Boolean variable. But since we won't be using Orchestrator in this example to stop the execution of the process, let's also add another condition related to the counter. So, we'll add a flow decision with the condition should stop true or counter equal to 43. We specified 43 because, as you can see, our queue has 42 items. Remember, in a real enterprise implementation, this won't be the case, as we'll most likely want to control the process from Orchestrator, especially given that the number of queue items will be dynamic. Next, at the right of the flow decision activity, corresponding to the true branch, we'll add a log message with the process has stopped. As for the false branch, this needs to simply go to the first log message activity and execute all the following activities one more time. Now let's give it a run. And we might as well monitor the consumption of the queue in real time by using the Monitor Queue option in Orchestrator. Now that it's done, we can check the execution both in the output panel and in Orchestrator. As you can see, in Orchestrator, the conversion to integer errors were logged in the error feed panel. Alright, this concludes our demo on populating and consuming Orchestrator queues. Thank you for watching, and until next time, happy automation!